a tablet from anywhere can look at the system throughout the day, throughout the night, and it does generate emails.
Right, and we
could schedule that. We could schedule that every hour if you wanted to monitor the system down to every hour. We could do that for all new leaks for every hour and have it set to any number of email people within the organization. We could set it up that way, fully programmable. This is what the top of the meter looks like. So it's an electronic meter, but it still has all the common values that you see, the decimal point. It will also have a flow. That last indicator will be the one if it's leaking, something like that, just like your current meters have a little red arrow, right? You'll just see that last digit rolling and moving. So same thing, they can look at the reading. The reading will be the same. If there's forward, backwards flow. Like you said, the alarm doesn't show up on the meter itself, but the flow, if it's empty or something like that, will be on there. There's indications, other indications on there in the bottom there. All that is displayable. In the future, if that's something you're looking for, I can talk to product manager. There is another release of this product coming out in the years to come that'll do temperature and pressure and all that kind of stuff. The technology is moving forward with these electronic meters, and those will be available to you within the next few years. And it can do cubic meters, cubic gallons, or gallons, whatever resolution that you want to set, we can set those. I think we're going to use gallons here.
And then we also have, basically, we'll have two-way communication between them and their water meter. For instance, like with DTE, with the smart meters, they can shut off your electricity if you don't pay your bill. We would have that ability as well.
We're going to have remote shut off on these in the next release, like Pearl 2, which will be out in the next few years. We'll have remote temperature and pressure and so forth. So technology will move forward on those meters. Yep. The FlexNet system is the actual tower, the whole infrastructure. It's what we call FlexNet. What Census calls FlexNet. It's gone through FixNet, FlexNet. It's been radio read. It's been called a lot of things through the years. This is the current term called FlexNet, right? And it's a flexible network information. The Census FlexNet network consists of a couple different things. We talked about I'll start on the upper left, the red box. Two-way smart metering, as you talked about. We can talk to the meter directly. We can do a final read through the billing system. We can, if there's a parameter change or a leak detection, you've got somebody that says they're going to be away, we can change all those parameters over the air. You don't have to go do site visits. Okay. The SCADA operations, all your pump stations and so forth, we can monitor those. This is kind of the future. We talked about leak detection. The communication network is the whole infrastructure. So we're talking about supporting this in the cloud or Census data centers. So the communication network is all redundant between all the different towers and the components of the system. That communication network I'll show you in a second. And then improve customer satisfaction through, like you said, the information of being notified. The billing information is available all the time through a very graphical interface, a dashboard map, which I'll bring up in a second. Okay. I know this is a kind of a tight overall what the architecture looks like. In the center is the base station, and there is a base station server box that Aetna sells and installs, works you with there. It talks to the meters. The stuff on the right-hand side is the SCADA information of the pump stations and so forth. Those are all future technologies. We can also support, we can control lighting, all your street lights. Again, electric, gas, and water. And then demand response or the home thermostats. We can also go all the way down to the home thermostat if in the future you want to do that. So it supports all that technology. Again, it's through the automated network interface is what we call the smart on the right-hand side, backwards here. It's information stores in a database. Currently, standard, we're using an Oracle database, so industry standard database, and the base stations use a Microsoft SQL database. So we're using both technologies, and it can be switched whatever. If you have a preference, we can switch those. So we support both the Microsoft database and the Oracle database. And then the infrastructure, I'll show you again in a second. Advantages of it, advanced long-range howe power. The FlexNet system is a point-to-point structure, covers wide area. You get a lease, you get your own frequency assigned to you. It's not a free frequency or something like that. It's yours, dedicated frequency that we resell the lease to you. You own the frequency. So if there's any interference from pagers or other companies or other technologies, you have the right, and we have a full FCC staff that will negotiate it and get those things turned off to stop interfering with the thing. We can monitor it. You can monitor it through the system if there's any interference on your system. Again, it lowers the initial cost because it's a single protected FCC licensed spectrum, no interference, and it also future-proof. We talked about some of the future stuff, the metering, the SCADA data, the demand response, street controls. It will all support all of that over that same infrastructure. So it will take you into the future. Software-defined radio, we talked about, we can change all the parameters, the leak detection. Any of the parameters can be changed over the air. Is what we call OTA, or over the air, at the transmitter or the collector. And then it's also a secure data. A lot of information about the smart meters is secure data. It's all private key encryption. In other words, so AE256 is 128-bit encryption. Would take you 10 years with a IBM mainframe to decrypt that. And that goes all the way down to the meter. The encryption of the data is all the way down there. And then we also encrypt it back at the data center. All firewall protected, the data moving back and forth. Redundancy, as I said, the smart points collect data and store it. The transmits mode, if they're in a location, if you're somewhere far out, or a tree or a truck parked in front of it, the meter changes mode, transmits at a higher value, and then drops back down. If we can't talk to it in a couple days, and we say that you talked about not reading 7,000 meters. If we see a group that we can't read or something like that, somebody's doing some construction or new buildings going up, we can change the mode on those transmitters to make them more powerful for that amount of time, and then kick them back. Again, stores all the data, backfills all the data if it's missing. The base station itself is in the middle. The only thing you need is from the base station to our data center is an IP connection, which I think they've probably talked about, or it's in the proposal of setting that up. You need to maintain that. That's all firewall protected. And then in our data center, the RNI is the regional network interface. Basically, the router is that we collect, and it's both data centers fully mirrored location and backed up every day at both centers. And we have a full pipe between both data centers, so if our data center in Boise goes down for some reason, a flood, a disaster, or something like that, the Raleigh station is coming back up. We also have one in Canada, but we don't. Canada has its old rule about storing data in Canada. So your data is secured, stored. These are SAS 70 data centers, so all the banking companies use the data centers also. So we lease the space from, they're not census-owned data centers, they're recognized data center company that secures other companies' data. Permalog is another technology out there for leak detection for the pipes in the system themselves that it supports, and it will support in the interface. It's acoustic monitoring. You put little acoustic monitors at 2-mile sections of pipe or something like that, and listen overnight for dripping water or leaks. So it supports that. The Customer Connect is that portal. So if you want to go in the future, the customers want to go in and look at their own readings and by hour and so forth, and get their own emails and their own text messages. That's available for future proof. As I said, remote disconnect will be available within the next couple of years. The distribution automation for SCADA, the monitoring your pump stations, is available today. Street lighting is in controlled release. We're doing a few towns, Chattanooga, and there's a couple of them that supported the new LED street lightings. And you can monitor that through the system, control the lights, blink them, lower the power whenever you want. So all that technology, because you own the frequency, there's no interference, you get full bandwidth, do all of that in the technology in the future. So it's lots of future-proof for the product. What we did for Taylor was a propagation study. Propagation study is you gave us a list of all the locations. You gave us a couple of tower locations. You can see the little dots in the center there. And everything in green is just like a bar on your cell phone. Everything in green is 5 bars. So we can read 99% of your meters with those 2 towers. So we did that for you, so we know this to pick up all the...
The towers are in place right now?
Yes.
Okay.
Yeah, we're using your existing structures that you already have.
Okay.
We're using one right here at the City Hall, and then on North Line at the DPW is
Okay.
in town. Those
And
would be
we've
2.
done tests. Aetna has done tests. Aetna has a portable truck,
Yes.
right? And has done tests and read the full square miles, what's square miles here?
24.
24. Yeah, with the 2 towers. A single tower will do maybe up to like 10, depends on the geographic layout of the towns and the hills. It's pretty flat here, so we pick up stuff and your antenna heights are pretty high, so 2 towers is great. And they're redundant, so if one goes down, it's going to be able to pick up most of the other stuff until the other tower comes
So
back
for
up.
the folks that you can't read there in the north end, how would you read that?
The 6 or 8 of those.
Yeah,
So those are just low, we probably turned the transmitters up on those boxes
Okay.
so that we can pick up. This is very conservative. We've done prop studies like this, Bill can tell you, we generate a lot of these for Aetna. And stuff in blue is fine, stuff in yellow is questionable, but you don't have any in yellow. So that's a 4-bar read, and it may take 2 reads instead of a single first read on it to pick it up. But if we don't get it in the first read, we pick it up in the next hour and backfill the data. So
We actually set the trailer up on Pardee by the library, and with our portable antenna with 100-foot, with the trailer with a 100-foot antenna on it, and we put endpoints all the way around the city and wherever the water department. So we did a demo, and then we engaged the computer. So basically, Taylor for a month, 2 months, got to kick the tires and have a live system up and running. So we were able to read everything with one antenna. So we're pretty confident that we'll get it all with 2.